Welcome to the DIY Honda Garage channel. DTC P2564 indicates a problem with the turbocharger wastegate control actuator position sensor circuit, specifically low voltage detected in the circuit. This sensor plays a crucial role in regulating the wastegate's position to control the turbocharger's boost pressure, which impacts engine performance and fuel efficiency. The turbocharger is located in the engine compartment, specifically near the exhaust manifold, and the wastegate actuator is usually attached directly to it. When this DTC is triggered, it may indicate issues in the electrical connections or the sensor itself that need to be addressed to restore normal turbo operation. It is important to perform a thorough diagnosis and follow the specific troubleshooting steps to ensure accurate repair and vehicle performance. The DTC P2564 highlights an issue concerning the turbocharger wastegate control actuator position sensor circuit, which has detected low voltage levels. The turbocharger is an essential component of the engine's forced induction system, enabling higher efficiency and performance. The wastegate actuator controls the valve that regulates exhaust flow to the turbocharger, thereby controlling boost pressure. When the actuator sensor circuit experiences low voltage, it can lead to underperformance or a lack of boost, negatively impacting the vehicle's performance. The turbocharger is typically located in the engine bay near the exhaust manifold, and the wastegate is mounted directly on it. Understanding the placement and function of these parts is critical for effective troubleshooting and repair. Several possible causes may trigger DTC P2564. Firstly, poor electrical connections within the circuit can lead to unstable voltage readings, which would affect the performance of the wastegate actuator. Secondly, loose terminals can create intermittent electrical contact, resulting in a momentary loss of signal and triggering the low voltage fault. Additionally, a faulty turbocharger wastegate control actuator position sensor may be the primary reason for the voltage drop. The sensor may have experienced internal failure, causing incorrect readings to be sent to the powertrain control module, PCM. It is vital to inspect these components carefully to identify any faults and provide proper repairs. When DTC P2564 is triggered, various symptoms may become evident. One of the primary indicators is a noticeable reduction in engine performance, particularly during acceleration, as the turbocharger may not be boosting effectively. This can lead to slower response times and a lack of power when the driver demands more from the engine. Additionally, the vehicle's check engine light may illuminate on the dashboard, signaling to the driver that there is an issue requiring attention. Furthermore, the turbocharger may fail to deliver its intended performance, resulting in decreased fuel efficiency and less power output. Understanding these symptoms can help the technician pinpoint the problem more quickly. In the first troubleshooting step for DTC P2564, the vehicle should be turned to the on mode without starting the engine. It is essential to utilize the Honda Diagnostic System, HDS, to check the parameters of the engine and assess specific voltages. One critical parameter to check is the exhaust wastegate, EWG voltage from the lift sensor. The expected value should be at or below 0.16 volts. If the values fluctuate above this threshold, this may suggest an intermittent failure or an issue with the components involved. If the current conditions match the parameters, it is advisable to move to Step 2 for further diagnosis. In the second troubleshooting step, the vehicle must be turned off completely before proceeding. Once the vehicle is turned off, the technician should disconnect the turbocharger's 5P connector, which is crucial for monitoring signals from the wastegate actuator position sensor. After this disconnection, turn the vehicle back to the on mode to recheck the EWG voltage again using the HDS. The expectation is that the EWG voltage will still measure at or below 0.16 volts. If it does meet the criteria, the technician should then progress to step 5 to check further electrical components. If the voltage is above this threshold, it suggests a deeper issue, compelling the technician to move to step 3. Step 3 involves measuring the voltage between two specified test points while the vehicle remains in the on mode. With the Turbocharger 5P connector disconnected, the technician will track voltages at positions designated by test points 1 and 2. Test point 1 corresponds to the female terminal number 2 of the turbocharger connector, and test point 2 relates to terminal number 3. The voltage measured should ideally be around 5.0 volts. If the reading aligns, the correct course of action is to replace the turbocharger due to a faulty position sensor or actuator. However, if the voltage does not meet expectations, proceed to step 4 to examine the wiring circuits. In the fourth troubleshooting procedure, the technician must ensure the vehicle is turned off. With the SCS line jumped and active for more than 1 minute, the next step is to disconnect the PCM connector E, which is key to controlling electrical signals. The technician needs to check continuity between the designated test points, one being terminal number 2 of the Turbocharger 5P connector, and the other being terminal number 77 of the PCM connector E. If continuity is present, it suggests that the VCC2 wire is functional, and a further check on related codes or symptoms might be warranted. Conversely, if no continuity exists, then the technician must repair any open circuits in the VCC2 wire between the PCM and the turbocharger to restore proper function. For the fifth troubleshooting step, once again turn the vehicle to the off state. After jumping the SCS line for the necessary duration, disconnect the PCM connector E to initiate the body ground continuity check. The technician should verify continuity between the Turbocharger 5P connector, terminal number 4, and the body ground. An essential check to ascertain whether there are any shorted wires in the DC-WGL line. If continuity is detected, it indicates problems with shorted wires and requires immediate repair of the DC-WGL wire connecting the PCM to the turbocharger. If no continuity is found, it suggests that the DC-WGL wiring is intact, and the technician should investigate further into authorized service information or consider substituting a known good PCM for additional diagnostic clarity. After completing the necessary repairs related to DTC P2564, it is crucial to perform a final verification to ensure that the issues have been effectively resolved. Start by reconnecting any connectors and clearing any existing DTC codes from the PCM. Recheck for new DTC codes using the HDS to confirm that no further errors are present. Finally, conducting a test drive will allow the technician to observe any performance changes and assess whether normal engine functionality has been restored. This final verification step is vital as it helps ensure that the repairs have addressed the previously experienced issues, thereby securing the vehicle's reliability and performance. To minimize the chances of encountering issues related to DTC P2564 and ensure ongoing vehicle reliability, preventive maintenance plays a significant role. Routine inspections of electrical connections associated with the turbocharger can help identify potential issues before they escalate. Technicians should also regularly examine the turbocharger components for signs of wear or damage, ensuring they remain in good working condition. Following the manufacturer's recommended service intervals and guidelines is equally critical to maintaining optimal performance and longevity of the vehicle's key systems. By adopting these preventive measures, owners and technicians can significantly reduce the risk of failure in critical turbocharger systems, ultimately preserving vehicle performance. In conclusion, DTC P2564 highlights an important issue linked to the Turbocharger Wastegate Control Actuator position sensor circuit, specifically signaling low voltage levels. Understanding the critical role played by the actuator in managing turbo performance is essential for successful diagnosis and repair. Following the troubleshooting steps meticulously ensures that technicians can identify and rectify issues effectively. Recognizing potential symptoms, such as loss of engine performance and triggered warning lights, aids in timely intervention. Equally, implementing preventive maintenance practices safeguards against future occurrences. Lastly, careful attention to repairs helps maintain the reliability and efficiency of Honda Accord vehicles from the model years 2017 to 2023. Please like and subscribe to the channel. See you next time.